Sadly, Ethan is not here with us today because he has come down with a sickness that we do not all want to receive. So he is going to be doing this speech virtually. Have you ever been walking around and something comes out of the corner of your eyesight? Well, this is your peripheral vision. Your peripheral vision is when you are staring at one fixed point and you notice something on the edge of your field of vision. Hello, our names are Cory,
Shri,
Jason,
and Ethan. And today we will be testing how different eye colors might affect the range of a person's peripheral vision and how long it might take them to notice an object in their field of vision.
while we tested this, we also tested to see if these people could make out certain characteristics of what they could see and when they could see it, such as the color of the object and the shape of it. We also tested to see if the dominant side of a person's body had better, worse, or the same peripheral vision.
Our group's hypothesis was that people with brown eyes will have better peripheral vision because most people in the world have brown eyes. We believe that this is because of evolution. If people have evolved over time to have mainly brown eyes, it must have been for a reason. So those people with brown eyes must have better peripheral vision.
Okay, so for our experiment, the materials that we used were cardboard, construction paper, a protractor, a ruler, a pencil, tape, a push pin, a cardboard tube, and a computer to record our data. In the end, after gathering our necessary materials, we got to work building our vision board. Now, when I say vision board, a lot of your minds might immediately go to something like a dream board or a bucket list that would have things you would want to accomplish in life. But our vision board looks and functions completely differently.
For our vision board, we had a cardboard board that is cut in a semicircle, in which the diameter is about 24 inches and the radius is about 12 inches. We also had a cardboard handle for the participants to hold while being tested. A push pin was also used, and this would tell the participant where to stare. And the push pin was positioned at exactly 90 degrees on our vision board. We then cut out a little piece in the semicircle for the participant's nose to go against. And finally, on the cardboard, we drew a big protractor so we could see exactly where they noticed the characteristics of the papers.
We tested a total of 9 participants, and we tested 3 different eye colors, which included brown, blue, and hazel. The 9 participants that were tested were us 4, Cory's mom, his dad, his sister, his brother, and his friend. We tested these participants by having them put their nose on the nose piece and stare at the push pin. Then we would put a piece of colored paper on the edge and then move it continuously and record when they could see the piece of paper. We also recorded when they could tell the shape and the color of the piece of paper. We then put all of our data into a data table so it was easier to compare it. We had a total of 6 pieces of paper, and each of which were the colors red, yellow, and green. And half of them had pointed tops while the other half had flat tops.
We also had many different variables in this experiment. Our constant variables in this experiment were the place where it was tested, the time of day we did it, the vision board we used, and the slips of paper used to test. These variables stayed the same throughout our entire experiment. The dependent variables in our experiment were when the participants noticed something enter their field of vision and when they could tell the color and the shape of the paper. Finally, our independent variable was the color of the participants' eyes and what we changed to get results.
All right, so during this project, we had 3 main roadblocks. Our first one was picking our project idea. Our first idea was to take different types of liquids and water plants with them to see which would work the best. But by the time we decided on this idea, it was too late to start. So our second idea was to take, again, many types of liquids and see how long it takes to freeze them. But this wasn't really STEM-based, and it has no relation to the real world, and nor would it help us. Finally, or next, we answered our question. We worked great, although we had to work hard and fast because of the delay. And after choosing and narrowing down our topic so it was as specific as possible, we were ready to conduct the experiment. Our second roadblock was the testing itself. It was hard to find people willing to do the testing, as well as people that had different eye colors than the ones we had already tested. People had schedules, we had to work around them, so we would have to test when they were available. And finally would be distractions by surrounding colors, and it changed how well people could see colors. It distracted them when the colors would blend in with the paper strips. Participants by natural instinct would also naturally look over towards the paper strip and accidentally see the one we held up.
So, after testing all the participants, we decided to make some graphs of the data to easily compare them. The first graph that we made was just seeing how many people of different eye colors we decided to test. As you can see here, 23.5% of the people we tested had blue eyes, 35.3% of the people we tested had brown eyes, and the remaining 41.2% of the people that we tested had hazel eyes. Now, based on these graphs that we made, left and right eyes does not make a statistical enough difference to consider it neurologically. It's just coincidences. However, unlike the left and right eye, the eye color did affect how well these people could see the colored strips. Blue eyes obviously outshone the rest in seeing them all the quickest. For example, the average time that people saw something out of their peripheral vision with blue eyes was 5 degrees. The time they noticed the color was at 13 degrees, and the shape was at 22 degrees. On the flip side, however, people with hazel eyes were the slowest at noticing these things, with an average of noticing the object at 9 degrees, noticing the color at 15 degrees, and the shape at 24 degrees.
Right in the middle, we have brown colored eyes. An average of them noticing the paper strip was the exact same as the blue colored eyes, so they were pretty close to each other. They had an average of 6 degrees for noticing, an average of 13 degrees for noticing the color, and an average of 14 degrees for noticing the shape. Now, on this graph, it shows which objects were hardest to see by all of the different eye colors. And it appears that green pointy took people with brown and hazel eyes the longest to notice the shape of the object. Other than that, green pointy was about even for the color and first noticing of it. Green flat also took people with brown and hazel eyes pretty long to notice, but not blue, which supports the conclusion that people with blue eyes have the best peripheral vision out of these three eye colors. Just like the left and right eye, however, the dominant side of the body did not have an effect on how well that person could see out of their eyes. Presumably because muscles in the skeletal muscle system have dominant sides that are typically stronger and more precise than the non-dominant sides, while eye muscles' dominant sides do not really have an effect on which eye sees better, but rather an influence on which eye leads the other.
So, with this said, our hypothesis was not 100% correct, because we thought that people with brown eyes would have the easiest time and be the best at seeing these objects out of their peripheral vision. Now, it's not like brown was the worst, so we weren't completely wrong about our hypothesis. We also noticed that brown vision was very close to blue vision, so it was a close race.
When we went looking for scientific research to back up our results, we found out that our data didn't really compare with the course of the world. According to Science Blurred, people with darker eyes tend to have a wider peripheral vision, whereas people with lighter eyes tend to have a narrow peripheral vision. This is because the darker the eye, the more the pupil opens up, which allows for more light to come in. On the other side, when they have lighter eyes, the pupil doesn't open as much, so not as much light enters into the eye. A reason to why our data didn't reflect this is because we didn't have the same number of people for each eye color tested. And just because most people in the world with brown eyes have an overall better peripheral vision than people with different eye colors such as blue or hazel, does not mean these other eye colors are lacking in the peripheral vision section. Another reason to why our data didn't reflect this is due to the colors in the background. This is because there were a lot of vibrant colors in our environment, which caused the pieces of paper to blend in, and it made it harder for the participants to see the pieces of paper.
So, after figuring this out, we realized that our hypothesis was correct globally. Because most people in the world that have brown eyes have better peripheral vision than others, it supports our hypothesis. This does not mean that the people we tested with blue eyes, my father and my sister, results were inaccurate at all. They were just outliers in the data. And they also had better peripheral vision than most of the other people in the world with blue eyes.
So, next time, if we had to do the same experiment again, there would definitely be some changes made. The first change would make it so we would test the same amount of people with different colored eyes, so our data was more accurate. The next one is to test the participants in both a light and dark environment to see how drastic the difference is and if there even is a difference.
Another change that we would make is to remove eyewear, such as contacts and glasses, before testing. Because Ethan had contacts when we did his test, it may have affected the accuracy of our results. And finally, we would do this in a white room, where there would be no distraction and no colors blending, which would make this testing a lot more accurate.
Thank you for listening and taking this journey with us. We hope that you can now apply what you learned here to yourself and your family and test them like we tested ourselves. See if your results correlate with ours. Thank you and have a good day. Here are our references.